ফোন দেওয়ার পর ফোনে পিক করে না এবং বলতেছে করবে না ওয়ার প্রেজেন্টেশন করবে। আপনাদের আইডি গুলো সিরিয়ালে বলবেন মানে কত থেকে শুরু হবে লাইনটা ওপেন করে তারপর বুঝতে পারবেন কত থেকে 104 204 217 20 আছে নাই কত তাই 225 নাই আর 226 আছে আপনাদের গ্রুপে না আসে না স্যার 226 ছিল তাও করবে না আচ্ছা 226 ছিল সে আসে না ওকে তাহলে আপনারা যে প্রেজেন্ট করবে সে বাদ দিয়ে বাকিরা এই পাশে এসে দাঁড়াবে।
Greetings everybody. I am William Halda. This is SM Sajid Mahamud. Then we have MD Asaduzzaman Moni. Following him, we have SM Naimul Hussain. Then we have Janatul Naim Siam, Abdullah Mamun, and finally we have MD Omar Farooq. We are all students of Northern University of Business and Technology in Department of Electrical and Electronics Engineering. We represent Group D. We have created the slide Thermochemistry, Enthalpy of Neutralization, Combustion, and Hess's Law of Heat Summation. This slide is presented to our beloved sir MD Shahrur Rahman. Now moving on, next we have our introductory slide. Basically, we will delve into the realms of thermochemistry. We will follow the key concepts of enthalpy of neutralization, combustion, and Hess's law of heat summation. This slide is about contents. All the slide names are listed over here. First is title, introduction, and obviously contents, objectives, enthalpy of neutralization, enthalpy of combustion, and Hess's law of heat summation, recap, conclusion, appreciation, resources, and finally questions. Moving on, we have objectives. The key driving forces behind creating this slide is first to develop and encourage working with PowerPoint. Second, to encourage teamwork and presentation skills. Third, to explore the concepts of enthalpy of neutralization. Fourth, to explore the enthalpy of combustion. And finally, fifth is to explore the Hess's law of heat summation. Now my friend Sajid will like to continue.
This slide is about the enthalpy of neutralization. Now, what is the enthalpy of neutralization? You may wonder. Well, the enthalpy of neutralization refers to the heat exchange occurring when an acid base undergo reaction to produce a salt and water. It quantifies the energy needed to neutralize the acidic and basic component. It is typically expressed in unit of energy such as joule. On the next slide, we have the importance of neutralization. Why is enthalpy of neutralization is important to us? The first and foremost reason that I would like to emphasize is the significance of energy change in the reaction. This concept helps us to understand whether a reaction is releasing or absorbing. The enthalpy of neutralization is a crucial factor in this regard. It provides valuable insight into the amount of heat energy released or absorbed during a neutralization reaction. When analyzing acid and base titration, enthalpy of neutralization values is often utilized. It is self-explanatory. The third point will be calorimetry and thermodynamics. It allows scientists to study and understand the thermodynamics of chemical reaction. It is not only crucial for understanding the energy change in acid-base reaction, but also from the basic model in chemical reaction. And finally, we have education and research. It serves as an example to understand the relationship between energy change and chemical reaction.
Hello everyone, I am Rashidul Munir. Today I will be discussing the factors affecting the enthalpy of neutralization. At this moment you can see the title is application of enthalpy of neutralization. We will be discussing the uses of enthalpy of neutralization in our day-to-day life. First, I would like to start with chemistry. It is used in chemistry to determine the amount of heat realized or absorbed during a neutralization reaction. Second, we have education and research. It serves as a valuable topic in educational system for teaching students about thermochemistry and its effect reaction. Researchers also use for studying reaction kinetics and energetics. In fact, we have biology that it is used to understand the energy changes that occur during metabolic reaction in living organisms. At last, we have environmental science. It is applied in environmental science to study the effects of utilizing acid rain or other acidic solution. Moving on the next slide, we have factors in the enthalpy of neutralization. In this slide, we have discussed two major factors will affect how neutralization reaction will behave. I would like to start three major points. In the first number is state and concentration of acid and base. The number one is the enthalpy change of neutralization is acid and bases tend to have higher changes compared to acid and bases. Number three is higher concentration of acid and bases can lead to large intensity. And the second is temperature. Here I would like to talk about 2 points. The number one is the temperature of the reaction can affect the enthalpy change of neutralization. The number two is the increase in temperature can lead to higher enthalpy change. In decrease in temperature can result in lower enthalpy change. The third point is in our slide. I will explain example of it. As you can see, in this video, the illustration and the chemicals. We can see two chemicals. One is hydrochloric acid and the other is sodium hydroxide. We will mix this chemical in indicator and together. Then the reaction will create sodium chloride salt and release water along with 57 kilojoule mole per aqueous and recreate water along with shown as in the equation. This is an experimental reaction which means the heat is released. Thank you.
The concept of enthalpy of combustion. The definition is that the enthalpy of combustion is a thermodynamic concept that react or represent with the heat released or absorbed during a combustion reaction. Combustion is a chemical process, chemical phenomenon which is a substance react rapidly with oxygen and generate heat and light. The equation of the combustion process is del H of combined is equal to summation of del H product minus summation of del H reactant. In In this slide, I will be focusing about the importance of enthalpy of combustion. Firstly, we have fuel efficiency. Understanding the enthalpy of combustion is vital for assessing the efficiency of combustion process, so fuel can be used efficiently. Secondly, we have education and research. It serves as a basis for understanding energy transformation in combustion process, combustion kinetics and thermodynamics. Thirdly, we have safety in combustion process. Knowledge of the enthalpy of combustion is essential for ensuring a safe operation in combustion. Last but not least, we have energy content of fuels. It provides measures and it qualifies the amount of heat released when a substance undergoes complete transformation. Now, in this slide, I will be representing you the application of enthalpy of combustion. Firstly, we have energy production. Understanding the enthalpy of combustion is crucial in designing and optimizing combustion process for energy production and success in power plant and combustion unit. Secondly, we have fuel selection. Enthalpy of combustion value say selecting efficient and cost-effective fuel for various purposes. Thirdly, we have industrial process. Industrial utilize the enthalpy of combustion optimize combustion process in various applications, including ceramics and chemical manufacturing. Last but not least, we have heating system. Enthalpy guides efficient heating system designed for maximum output in homes and business. Thank you, sir. I would like to present my teammate Danatullah and Sam to continue the service.
I will discuss the factors affecting of enthalpy of combustion. In this slide, we have the only three major points to discuss. First, amount of oxygen. The availability of oxygen affects the combustion process. Insufficient oxygen can result in complete combustion, leading the lower enthalpy of combustion. Secondly, we have the type of fuel. Different type of fuel enthalpy of different type of fuel have different enthalpy of combustion. For example, fossil fuel like coal and oil have higher enthalpy of combustion compared to natural gas. And three, presence of impurities. Impurities in the fuels can affect the combustion process enthalpy. Combustion process and the enthalpy of combustion. For example, impurities like sulfur can result in the formation of sulfur dioxide, which affects the overall enthalpy. In the next slide, we have an example of combustion of methane. Here we have the reaction of methane and oxygen. Methane reacts to oxygen and it creates carbon dioxide and H2O water. The enthalpy change of this reaction is minus 890 kilojoule per mole, and there is a graph of this changing reaction. Thank you.
Thank you, Danatullah and Shyam. Assalamualaikum, sir. I am Abdullah Bawan. Today's my topic is test of heat solution. The law states that the total enthalpy of the chemical reaction is the same, regardless of the numbers, steps or steps in the reaction. On the other words, the overall reaction of the enthalpy changes is independent to the pathway taken from the initial to the final steps. Moving on the slides. I will be discussing about the importance of Hess laws of heat solutions. In the beginning, we have definitions of enthalpy changes. Hess laws provides a method experimentally determined the enthalpy changes of the reaction that may be challenging to measure directly. After that, we provided the prediction of reaction stability. That is the ability of manipulate and combine chemical reactions. Predictions of reaction of stability that is allows for the stability of reaction that may not occur directly. Thirdly, we can discuss about the thermochemical data and compilation. It is often Hess clause is implied in compilation of thermochemical databases. This provides a comprehensive set of enthalpies in various reactions. And the last points, we have got the compensation of energy. Starting the total energy changes for a chemical reaction is the same regardless of the pathways taken. This aligns with the fundamental reactions is the principle of energy conservation in the thermodynamics. Moving on the next slide. We can discuss the calculating of expenses using of Hess law. First of all, identify the target reaction of which you want to calculate the enthalpy changes. Secondly, break down the target reaction. Into a series of intermediate reactions is known as enthalpy values. Thirdly, manipulate the intermediate reaction to obtain the target reactions by reversing and manipulating observes as necessary. At last, we can discuss the topics add up the enthalpy changes of the intermediate reactions, obtain the enthalpy changes of the target reaction. Now I am invite our team leaders to discuss about this topic.
Thank you, Abdullah Babu. My name is Sanjay Farooq. In this slide, I will explain an example of Hess's law of consumption. Here we can see an example. Sulfur plus 2 mole of oxygen and produce sulfur trioxide. The conversion of solid sulfur to form sulfur trioxide happens in two steps. The first step, sulfur react with oxygen and produce sulfur dioxide, where the enthalpy change is minus 2.7 kJ. In the second step, sulfur dioxide react with half mole of oxygen and produce sulfur trioxide, where the enthalpy change is minus 9 kJ. The overall reaction will be obtained by added these two steps. The enthalpy. Remember that when we add two steps, the molecule that appear in both sides of reaction is arrowed are cancelled out from the both sides of equation. By adding these two steps, we get sulfur plus 3/2 mole of oxygen and produce sulfur trioxide, and the overall enthalpy change is minus 297 kJ plus minus 99 kJ is equal to minus 396 kJ. Moving into the next slide. In this slide, I will give you a brief explanation of the real world uses of Hess's law. The topmost topic is industrial process. Hess's law applied in the design and optimization of industrial process, where enthalpy change can play a crucial role. It helps engineers and scientists to predict and control the energy change in chemical reaction. In the next comes biochemical reaction. The law is applicable to biochemical reaction, aiding in the understanding of the energy change during a process such as cellular respiration and photosynthesis. After that, we got bond energy calculation. The law is applied to calculate bond energy by breaking a reaction into steps involving the breaking and formation of bonds. Hess's law helps determine the overall energy change of the reaction. At last, we have fuel combustion. The study of it, especially in the context of fuels, Hess's law can be employed to calculate the enthalpy, which is associated with the combustion of the combustion process. That's all of it. Now I will invite my friend William Mohammed to present. Now, after all of that, I would like to summarize everything that you have heard from the previous slides. So, first is enthalpy of neutralization. Enthalpy of neutralization is the enthalpy change during a neutralization reaction. Studying these reactions will enhance the knowledge in our basic chemistry, but also has many practical implications in our day-to-day life. Next is enthalpy of combustion. Enthalpy of combustion is the energy released during a combustion reaction. Studying this will give us provides insights to efficiently use energy and help and provide us with environmental impacts on combustion process. Next, we have Hess's law of heat summation. Hess's law of heat summation says that regardless of the path taken, the enthalpy of total chemical reaction will stay the same. By using it, we have dissected complex chemical reactions into smaller reactions. Showcasing the elegance of thermodynamic principles. Now finally, in the conclusion, our journey through the realms of thermochemistry has provided us fascinating insights about it, from the Flaming neutralization reaction to the fiery combustion reaction and the intricate calculations of Hess's law, we have delved into the very heart of enthalpy transformation. Now next, we have references. These are the websites named that helped us to create these beautiful presentations. And finally, appreciation. On the behalf of my teammates, I thank you all from the deepest depth of my heart for being with us and hearing us. Thank you.